subtopic number 7, which is on electrical energy and power. So in this subtopic, you should be able to use the formula of power, which is equal to PIV, I square R and V square over R, which is known as power loss. Okay, and you also have to be able to use electrical energy, which is equal to work, which is work equal to VIT. Okay, so electrical energy, which is E. So let's consider a circuit consisting of a battery that is connected by wires here to an electrical device. Okay, so the potential difference across this electrical device is V. Okay, so if a current is flowing from terminal A to terminal B here, if it flows for a time t, the charge can be calculated using the formula here. Okay, so the work done on this charge Q, on this charge from B to A, is equal to the electrical energy supplied. Okay, so it is equal to the electrical energy supplied. Okay, remember charge moves from negative to positive. Okay, so we can calculate that electrical energy by using this equation here. Okay, so if the electrical device is a passive resistor which converts all electrical energy into heat, the heat dissipated can be calculated using this equation here ataupun yang ini juga lah. Okay, okay. That is on electrical energy. For power pula, it is defined as the energy liberated per unit time in the electrical device. Okay, so the electrical power supplied to the electrical device is given by this equation here. Okay, so they're equal to PIV ataupun work over time ataupun VI over T. Mana-mana yang ada, kamu gunalah whichever equations yang ngam, the formula yang ngam. Okay, so when the electric current flows through the wire, the passive resistor, the potential difference across it is V equal to IR. Okay, so the electrical power can be written as the one shown here. Okay, this one here is also known as power loss. Okay, power loss. Okay, sometimes the question will ask you about power loss juga tuh. Okay, berapa banyak power loss. Okay, now combination in cells pula. Okay, so they are cells connected in series, battery connected in series ataupun batteries connected in parallel. Okay, so the total EMF and the total resistance are given by, untuk the total EMF for batteries connected in series is just the addition of the EMF, similar to the internal resistance. Okay, but if one cell, contoh yang ini, dia pergi, instead of like this, it becomes like this. Dia berubah pergi this direction. Okay, dia akan jadi this value here. Okay, sebab sekarang ni diorang in opposite. Consider ini dengan yang ini. Okay, so dia akan, instead of tambah, the EMF will be EMF 1 minus EMF 2. Okay, tapi the internal resistance remains unaltered lah. Okay, untuk cells in parallel pula, the total EMF and total internal resistance are given by this equation. Okay, so the EMF will be equal lah for both. Okay, so EMF is just equal to the EMF 1 lah. Alright, so if different cells, untuk internal resistance pula, it is calculated like this. Okay, so if different cells are connected in parallel, there is no other simple formula for the total EMF macam yang ni, it is the simple formula. But if they are connected, if different cells are connected in parallel, kita have to use Kirchhoff's law lah. Maksudnya ni kalau dia terbalik, instead of like this, ada satu tu begini. So we have to use Kirchhoff's law. Right, tapi yang ini untuk yang simple punya connection lah. Right, so that is for subtopic 3.7.